So the first thing is you're going to be asked to plot data on a graph. If that's the case, there is a tolerance level of getting the answer correct. You don't have to be perfect. You need to be close, but you don't have to be perfect. So if you're plotting these points here, so if you plot the point 14, 39, if you go onto your or on the actual problem itself on MyOpenMath, this right here, this is definitely not the exact location of 1439, but it's close enough. So make sure when you're doing that you give it some care and concern, and you try to be close. So 20, 35, 28, 29. Again, as you're plotting this information, 40 and 21. And then 42 and 15. Again, it's not anything that is exact, but it should be pretty close. And now they may also ask you, after you plot that, they may ask you to sketch a line of best fit. And what the line of best fit means is it's a line that you estimate that has on average the same distance from each of the data points. Or the easiest way to provide the sketch for it is you want it to kind of go through the path that you see the data set is setting a trend for. So it's also called the trend line. And there should be approximately the same number of points above the line as there are below the line. So when you sketch it, that's a pretty good general rule. So here you have these 5 points here. So as you kind of sketch your line, as you draw your line in, obviously it'll be a little more exact than what I have. But if you draw it in doing something like this, where you're pretty close, you're right on where the line is trending in this direction here. And when you look at it, the distance from each point to the line, they seem relatively consistent, and there's the same number. Again, we have an odd number, so there's 3 points below it and 2 points above. Again, it generally will be, or as a general rule, will be a nice, easy, accurate form. Okay? Once again, there's a tolerance level for this. It does not have to be perfect. Okay? But when you do write when you actually determine the equation for the line of best fit, there is a right answer. Okay? And so you do need to use your calculator for that. But I want you to understand that the points and the line of best fit need to be pretty close, but they don't need to be perfect. All right. So let's talk about how to use your TI-89 to find that line of best fit. Okay. And so go ahead and take out your TI-89. And what you're going to do is you need to find the data matrix editor. All right, the data matrix editor can be found by going into the apps. It's also found when you turn it on and you have the icons showing. And you can either scroll through the icons to find it, or you can hit the key that's associated with the letter of that. So data matrix editor is associated with the letter D. So if you turn your calculator on, you hit the button here that has the D letter, it should go right to it. If you're inside your calculator or already in the home screen, you can access the data matrix editor by hitting this apps button, this purple apps button, and then just scrolling through and finding it. Okay, and when you hit enter, it's going to give you the option to go use the current one, to open one that you've saved, or to create a new one. Okay, so more than likely, generally, you're just going to use the current one. But right now, if you guys hit current, it's probably going to force you to create a new one because you probably don't even have anything in it. Okay, so what we're going to do, so for me, I'm going to go back and I'm going to set new because this is likely what you're going to see. All right, so it's going to give you or bring up this screen, okay, and make you create a file that you're going to use. My recommendation is just create a file. You don't have to create a file for every individual problem you do. Just create a file to start with. I'm going to call it, when I set this up, okay, you want to make sure it's a data. So as far as the type goes, okay, that we want it to be data. So make sure you select or that it's set to data. And then in the variable, that's the name that you're going to give it. And I'm just going to call this ALG2, algebra 2. So this is what I'm going to use for algebra 2. So ALG, deselect the alpha key 2. And when I hit enter, okay, I've created my new file. Again, mine's already been created, so I'm going to go back into that. But you guys can enter or create your own new one. And now, if you happen to have data in your entry field that you want to remove, what you can do right when you enter this is hit the F1 Tools tab, okay, and we can clear it by hitting number 8. It'll clear the data, confirm it, and now you can start filling in the new information. Okay. When you fill in your information here, it's just like a spreadsheet on Excel. Okay. You're going to use columns and rows. Okay. So C1, C2, those represent your columns. I'm going to put my X coordinates in column 1, my Y coordinates in column 2. So as I go through and enter this data, what I'm going to do is I'm just going to work all the way down column 1 first. So 14, when I hit enter, it just jumps down to the next row. So 14, 20, 28, 40, and 42. I'm then going to use my cursor and I'm going to scroll over to column 2. And I'm going to move up and go, I'm going to enter my corresponding Ys. So 39, 35, 29, 21, and 15. Okay, so those are the first 2 steps. You're going to open the data matrix editor. You're then going to enter the data. All right. Once you enter that data, what you're then going to do is perform the regression calculations. Okay, and so that's located here under this F5 Calculate tab. Okay, so if you hit this F5 Calculate tab, what we want to do is we want to choose a calculation type that is the type of regression we're looking for. Okay, so here you're going to take your calculation type. Okay, and I think it spells with a capital R here, but there's several different types if you scroll to the right. Okay, and so you see linear regression is the one that we're doing right now. Again, we'll later deal with exponential regression, cubic regression. We'll deal with power regression. Okay, but right now it's just linear regression. So for me, that's option number 9 or number 5. So I'm going to set my calculation type to linear regression. I'm then going to scroll down into my X and Y, and I'm going to identify the column in which I contain those data sets. So column 1 is my X's, column 2 is my Y's. So here for column 1, it's already alpha locked even though you can't see it. So if I hit the button that corresponds to C, it pulls up a C. Now I can see the alpha lock, so I want to deselect that because I'm talking C1. Scroll down to the Y. The Y column is C2, so now I do have to alpha key it, so C2. The next option below that is an optional one. Okay, I would recommend that you use it, and that is to store the regression equation to a particular function in your Y editor. Okay, so we can scroll over and we can put it into the Y1, Y2, Y3, whatever you want. Again, we're not saving anything that's in there, so I'm going to store this as my Y1 function in that Y editor. And once I do that, I'm good. I can hit enter. And when I hit enter, it's going to pull up the information that gives me my linear equation. Okay, what you're going to have to do is you're going to have to be able to interpret this information. Okay, up at the very, very top, depending on what type of regression equation you selected, it's going to give you a basic form. So here my basic form is y equals ax plus b. It then tells me what my a value is, tells me what my b value is. It gives me the correlation coefficient, okay, and the r squared value. We'll talk about the correlation coefficient in a bit, but for the most part, the closer that is to 1, the more accurate the line is for all the data points. If you get one that fits directly on a line of best fit, then that number would be 1. Okay, but the closer it is to 1, the more accurate. Okay? And then it also tells you whether it's positive or negative. Okay? If there's a negative, if it's a negative number, it's negative correlation, right? Or as x's increase, the y's go down, or the slope of the graph goes down. If it's a positive number, it goes up. Okay, so if we look at what we have here, and you do need to look carefully. So if you have bad eyesight, or if your calculator screen is hard to see, you might have to change the contrast on it. But you do need to be able to notice here, my a value is negative, which makes sense, right? Because I drew my line straight down, or down, so I knew it was a negative. So if I round this to 2 decimal places, I have negative 0.80. Okay, so I'm going to have the equation y equals negative 0.80x. And then when I look at my y value here, or my b value here, it's 50.73. So plus 50.73. So this is my equation for the line of best fit. And now, let's say I was working through this and somehow I lost that screen. Okay? You don't have to go back and do all that calculating again because you've stored it in the regression equation. Okay? Meaning if I go back to my home screen and I just type in y1 of x, this is going to pull up the exact equation that's in my y1 editor. And it tells me here, again, it wrote the constant first, but 50.7319. And if I look, here's my slope, negative 0.796 x. So that gives me my equation directly. When you enter, if you're entering an equation, you use this rounded form, whatever they ask you to round to. If you enter a value, meaning if they ask you to find what would the predicted value be when time was 50 seconds or 50 minutes, or when time was 10 minutes. If you had to evaluate that, you need to use the exact function. Don't plug it into this form. Plug it into what's on your calculator. Okay, so on this problem, so this is all we needed to do, was to find the equation. But let's say I asked you to make a prediction at, let's say, 5 minutes. Okay, if I asked you to make a prediction of what the weight would be at 5 minutes, the way that you would do this is you would take your function y1 of, and you place that number 5. So if I went back to my calculator and I did y1 of 5, close that off and hit enter, this would be my predicted mass, 46.75. Notice I did not plug that number in here. If I had used 5 in this function, so negative 0.8 times 5 plus 50.73, and enter, I would get a slightly different answer. Okay? The answer that will be correct is the exact answer. Okay? So you want to use the exact calculations for as long as you possibly can. You only round at the very, very end. Well, because this is rounded. And so when we used the calculator, it used the exact value, so it had the remaining decimal, and that's enough to make a difference of 0.02. Okay, so that's why I want you to make sure you use the exact values for as long as you possibly can. You only round at the very, very end of your problem. All right. Now, when you look at this data set here, so what you see is your values of x go from here to here, right? Okay, so your lowest value is a time of 14, your highest value is a time of 42. What that means is if you are trying to make a prediction based on this model that falls outside this range of x's, so outside of 14 to 42, this is called extrapolation. Okay, and I'll talk about this on the next. So extrapolations occur here and here, anywhere to the outside of where the data set is including. If you're trying to make a prediction, let's say, on what would be the mass at 32. So now 32, we don't have the time and mass measurement for it, but if we predicted that based on this and the time fell in between the region that we actually have modeled, then it would be called interpolation. Okay, so if you make interpolation, it's within the boundaries of your the values that you've tested, and if you make an extrapolation, it falls outside, either before or after.